Are you enjoying the conference so far? Yeah? Cool. And now let's have even some more fun. Okay. The thing is working. Let's hope the projector is not going to die on me. So everything is just going to be fine. So today I'm going to talk to you about data validation with cats. Don't forget to rate this talk and say that it was awesome. And now let's start with it. So, hi, my name is Daniela, and I'm an ex-Java developer. I know, we all have been there. So when I was at university, they didn't taught me anything about functional programming. All the time was objects, gang of 4. And then I started with Scala, and suddenly I was a little bit embarrassed because everyone was saying, now forget about all the things that you have learned so far. Now we start again from scratch. And for me, it was a little bit of a shock. It's a great process to go through. I really enjoyed myself, but at the beginning was a little bit hard to do. I'm not a mathematician, so I have some basic mathematical knowledge, but I'm not a mathematician, so I don't know the advanced stuff. Most of the things that are the backbone of functional programming, I didn't know them. I had to learn them. So it was a little bit traumatic for me. And because of that, I've decided to create a talk that doesn't use any functional word, and you will still get the point. Obviously, terms are useful, makes life easier, but at the beginning, forget about the words. Just try to understand the concept behind them. Okay, so now I'm not intentionally going to name things, because I don't want to scare you off. But obviously, I'm going to be around, so if you want, just come and find me, and I will tell you all the scary names of all the things that I've presented to you today. So I'm going to talk to you about data validation. Well, why am I going to talk to you about data validation? Because everyone has to do it, right? As soon as your application accepts some data, you are basically sure that you will need somehow to validate it. And validation can become pretty messy pretty quickly. So there are what I call two types of validation, the technical validation and the business validation. The technical validation is something like, does this record exist? Does the user have the permission to perform this operation? And the business validations are something more on the line. Given his data, can he ask this information? Can he do stuff like that? And he really, in particular, the business validation just change really quickly. And it needs to be maintained. And if it's not well structured, it will be a mess really soon. And as I said before, everyone has to do it, right? Everyone has to do it. So we don't want to reinvent the wheel over and over again. I mean, we could, right? But we want to focus on the new challenges of our project. We don't want to solve the same problems over and over again. So this is the goal of our talk, is how can I validate my data without going crazy and reinventing everything from scratch every time. So now, really quickly, I promise, I know it can be boring, I'm going to just super quickly review the key actors of our game. So the first one is map. What is map? You basically have a wrapper, and this map allows you to access the value inside this wrapper and to modify it. So for example, we have some Daniela maps, and then we had a yo. We will return some yo Daniela. If there is no value to access, guess what? Nothing is going to happen, right? So this is the idea of map, having a container, and we access the value inside. What happened, though, if the value inside my map returns a container? So you will have container of value. In this example, you will have sum of a value. That's stupid, right? We don't want something that maybe is going to be there. We just want something that is maybe going to be there. So there is this beautiful thing that is called flatten that basically just gets rid of one container, and we're all happy. And this pattern is so useful and so common that they decided to create a function that is just the combination of the two that is called flat map. Nothing else. Okay? And last bit of our game is for comprehension. If you have a map and you have a flat map, then you can write this nice syntactic sugar where basically it's going to sequentially compute the values, and it will stop as soon as one of the values in the chain is empty. So for example, here you have sum of 1, A will contain 1, sum of 5, B will contain 5, and we sum the two values. In the second case, if B cannot really contain any value because it's empty, the whole thing is going to be none. Yeah? Everyone with me so far? Yeah, we know this stuff, right? Cool, and now let's start our game. We are going to play a little game that is called What's Wrong with My Code? So, see, beautiful HTML. People that say that I cannot do front-end, they are lying. This is beautiful. This is going to be our case study. So we will have a beautiful form with an email, a phone number, and we want to write a function that represents the validation of this beautiful form. Of course, this is a simplistic example of our problem, but you will see it will be enough to highlight all the problems of our solution. So are you ready to start our game? Yeah? You're pumped? Cool. OK, so we just started with Scala. We come from Java, and we're not cool yet. We don't even know that Scala 2.12, Scala 2.11 is not the latest version. So it's fine. We will learn. We will get there. So let's start with Scala 2.11. And we come from a Java background. We know options a little bit. So we are familiar with it, so we go for it. So what are the options? Really quickly, they are in the Scala package. And you basically have two possible implementations, a sum of a value and a none. And you have a map, and you have a flat map. What this means is having a map means that you can easily access the value inside. Having a flat map means that you can write a full comprehension. Right? And just to be crystal clear, this is how you use an option. It's just an example of how you can create an option. We all know about this, so I'm not going to spend too much time. OK, ready for the first round? Yes, OK. Come on, clicker. Thank you, clicker. OK, so this is our first implementation. We have a case class, data that has an email and a phone. That's just the representation of our form. Then we have a function that is called validate email that takes a string and returns an option of a string, meaning if the email is valid, we will return a sum containing the email, otherwise it will return none. Same for the phone. And then we have this beautiful function, validate data, that takes the case class, then validates the fields, and then puts everything back together. So don't say everything, please, because this is just the beginning of our journey. What's wrong with this code? Sorry, say again? You can construct data that is not valid from the start. You might be right, but that's not what I'm looking for. Other people? The guy on the gray shirt? Exactly, you can say what went wrong. Sorry, you're too late. What does this mean? So let's assume that the email is correct. So here I will have a value. Phone is correct, here I will have a value, it's fine. But what if the email is wrong? The whole thing will return null. What if the phone is wrong? It will go here, then it will break, the whole thing is none. What if they're both wrong? Still, we will get none. This is clear if we explicitly use the function. So here, if we say, OK, email, OK, phone, we return the data. In all the other cases, we just return none. So can anyone tell me what went wrong? Not really. You don't know. Is it the email? Is it the phone? Is it both? So don't do it. Don't do it. If that's all you're looking for, just use Boolean, and we will like you anyway. Option is great, but it's not great for validation. What we are actually trying to do here is a little bit more. We want to tell exactly why and what went wrong in our validation. OK? Cool. Round number 2. We know about either, right? Either is from Scala util and basically has two implementation. Left that contains a value and right that contains another value. And the reasoning is either going to be a good value or is going to be a bad value. So it's one of the two, right? We don't have a map. We don't have a flat map. So we cannot access the value easily, and we cannot write a nice full comprehension. Remember, this is Scala 2.11. It's not Scala 2.12. What we have instead is what they call left-to-right projection. You basically indicate which side you want to map on. It's a little bit weird, but it kind of works. And you have a map and you have a flat map. So it's cool. And this is how we use it. It's fairly standard, basically. This is the only bit that changed. Cool. Round number 2. OK. This is our code. So case class, data that has an email and a phone. Then we have a function, validate email, that takes an email that returns an either a list of strings or a string. Note, this is a list, because multiple things could be wrong in an email, right? Same for phone. And then we have our beautiful validate data. We validate the email, we validate the phone, and then we just try to put a match. So we just say valid email, valid phone, and then if they're both right, we return right of data. If they're both wrong, we return a left, and we combine the lefts. Then if just one is wrong, we return that. If the other one is wrong, we return that. What's wrong with my code? Exactly. If you have 20 fields, you will get crazy. Not just 20 fields. 3, 4 fields are enough, right? How many cases you are going to go there, right? It's a code that works, but it's just not maintainable, right? We don't want to go crazy, try to match over all the possible cases. It's just, no, it doesn't work like that. So the code works in the sense that when we use it, it works when we pass both the values that are OK and return the case class. And if we pass both the values that are wrong, it will return both the errors. It works. It's crazy code, right? We don't want to be crazy. We want to be able to scale our code together with our validation. There is another little problem in this code. That is, who is saying that the right is the correct one and the left one is the wrong one? No one, right? It's a convention that we assume. Obviously, English helps a little bit here because right is right and left is wrong. But I live in the UK. I've been telling them that they are driving on the wrong side of the road, and they still do it, right? So there are people that would argue that left should contain the correct value. We don't want to have that discussion, basically. We just want to have one way of doing it. We don't want to discuss it further. What we say, because we don't choose where to map, is that either is not biased. We have to tell which side we want to map on. And as I was saying, that it's not really a maintainable code. So if you try to add a few instances, then the pattern match will just explode. Okay? So we speak with our more experienced colleagues, and they say, oh, come on, don't use Scala 2.11. Scala 2.12 is out. You should definitely going to try it out. So we try it out. And we discovered that in Scala 2.12, we have either. This is exactly as before, with the only difference that we do have a map and we do have a flat map. What that means is that you can access the value and you can write the full comprehension. You still have the opportunity to say, actually map on another side, but by default, they will assume that you are mapping on the right side. And this is how you build it. It's basically same as before. Nothing has changed. Okay. Cool, new round. This is our code. So, case class, data, takes an email and a phone. And we have a function, validate email, that takes a string and returns an either list of strings or a string. Same for phone. And then we have this beautiful function, validate data, that takes the data and returns an either a list of a string or a data. And because now we say that either is right biased, we can write a beautiful full comprehension. So we can validate the email, then validate the phone, and then put them together. OK, what's wrong with my code? It will fail on the first left. That's correct. So the cool kids call this is failing too fast. What does it mean? In that if I pass both the email and the phone that are wrong, it will validate the email. It will see that it's wrong, and it will not even look at the phone. It will just fail too fast. It fails once, and then it stops. And this is really clear if we look at how we use the function. So if we pass both the values to be correct, it works. If we pass just one that is wrong, it kind of works. But if we pass both the values that are wrong, it will just return the first one, because we are using a full comprehension, so it will run them sequentially. So that is not quite cool. Let me be extremely clear what I mean. Imagine this beautiful designed website with 3 fields, right? And we fill them out intentionally to be bad values. What our function is doing is that is validating the first value, saying, OK, that's bad, change it. We change it, and we submit it again. And it's saying, oh, now it's the second one that is wrong. Change it again. And now we submit it again. Oh, now it's the third value that is wrong. Submit it again, right? What we actually want to do is, given a form, we want to have the whole form highlighted with all the errors. Just tell me everything that is wrong, and let's move on with it. I would never use a website like this. I don't understand why a function should do the same. Just tell me everything that is wrong so that I can take actions once, and then we can move on. So either is cool, but it doesn't support what is called error accumulation. So if you're sure that you will always have only one thing that is wrong, you could use it. But as soon as you have multiple things that could go wrong, it's not that cool anymore. OK, so standard Scala options, well, choices don't really work for us. Let's have a look around what we have out there. And we discovered that we have a library that is called cats. OK, that's cool. It has lots of stars in GitHub, so it's promising. So let's see what cats can do for us. The first thing that cats can do for us is that if we are stuck on 2.11 for some mysterious reason, we can still have our either to be right biased. All we have to do is to import this magic thingy. And our either is going to be magically right biased. But we have seen that this doesn't really work. Either doesn't fit our problem. If you guys know cats, this is basically what it was called once XOR. It's basically exactly the same thing. Okay, not quite there yet. So let's look more at cats. And we discovered this little guy that is called validated. Okay, so validated lives in cats.data, and it has two possible values, a valid that contains a value and an invalid that contains another value. The name is already promising. It's clear what it's correct and what it's not. So there's not going to be any discussion around what's right and what's wrong. We have a map. It means that we can easily see what's inside the wrapper. We don't have a flat map. And that's kind of cool, because we have seen that we want to prevent people to write full comprehensions because they don't work, they fail too fast. But we have something else that is really useful, and this something else is called apply. I'm not going to go into the details of what apply is, otherwise I would break my promise. But if you are brave enough, it's a beautiful link of the CATS documentation that will tell you everything that there is to know about apply. And basically what it does is that there is this crazy symbol. It's really crazy. It basically does the same of the pattern matching. So it will try all the combinations. It will check if there are any invalid instances and combine them together. If there are no invalid instances, meaning that everything is valid, it will apply a function to all the values inside the valid. This crazy symbol has a crazy name that I'm not going to mention, otherwise I'm going to scare you off. So in the US, someone told me that it's called the Cinnabon symbol. Other people call the TIE fighter symbol. I'm Italian, so for the purposes of this presentation, I'm going to call it the pizza symbol. Please be aware, it's not actually called the pizza symbol, so don't Google it. You're going to be disappointed. But let's see how we can build a validated. We have two options, basically. The first one is basically the same of what we have before. So we have a valid constructor, and we have an invalid constructor. We have imports that are a little bit weird, but we can live with them. Otherwise, if we want to have a little bit more clear implementation, we can just use this called smart constructor. It's basically exactly the same. It's just more explicit on what we mean with that. Yeah, everyone with me so far? Cool. Next round. So this is our code. So we have a case class, data that contains an email and a phone. Then we have a function that is called validate email that takes a string and returns a validated of list of a string or a string. Same for the phone, and then we have this beautiful function validate data, where we validate the email, validate the phone, then the crazy symbol comes in, and the crazy symbol will check if there are any invalid instances. If there are, it will combine them and return them. Otherwise, it will just extract all the values that are valid and apply a function on them. Yeah? Cool. What's wrong with my code? Okay, I'm not going to let you suffer. It's fine. It works. It's beautiful. It's beautiful. And basically, the reason why it works is because instead of computing the values sequentially with a full comprehension, we are computing them in parallel. Note, this is written in one line. How cool is that? That is the indication that everything is computed in parallel rather than in sequence. That is super cool. I love this. And as I was saying, it works. It works, right? Beautiful. So if we pass both the values to be OK, well,
just return the case class. If we pass both the values that are wrong, it will return both of them, and so on and so forth. Okay. Can we do better? Can you guys see anything that is not exactly not ideal? Yes. Sorry? With free fields, we will just add another crazy symbol and then the thingy. So it's just adding code, so it's fine. Can you do a sequence and then map over the symbol? Sorry?
So you have a sequence, valid email, valid phone, and I don't know what, and put them all in a sequence?
So can you put all the values in a sequence? I think you can, but that's not where I want to go. So try again. Yes? What about validation of multiple fields? No, it's fine. It's fine. You will just add a validation that involves multiple fields. Yes, last one, and then I'll tell you the answer. How does it know how to merge the errors? I'm going to say a magic word. Don't be scared. Semigroup. I'll tell you later what they are. It's fine. There is a semigroup defined, so it knows how to combine them. Because we're using a list. But we are diverging here. So, things that we can improve. So, can we return with this current implementation invalid containing an empty list? Yes, we can. And what we are saying basically is, sorry, dude, it's invalid, but I'm not going to tell you why. That's not cool. We want to prevent people to do that. We want to force people to say, if it's going to be invalid, you need to guarantee that you are going to tell me at least one reason why it's not valid. And miles thought of everything as usual. So we have this beautiful thing that is called validate nail, that is composed by a not empty list that has this type. And then we just have an alias where null stands for not empty list that is associated to validated. Okay? And just as before, how do we construct a type like this? Same as before, the invalid bit looks a little bit uglier. But thank God we have an alias that makes it really easy to construct a value from that. Okay? Anything else that we don't like from a type point of view? Well, something that is not too cool is the fact that the error is a string. There's nothing wrong with having a string. The problem is that probably you want to do something with this error, and you want to have some kind of structure. String is a little bit too flexible, it's easy to change. So maybe it will be better to just choose something, anything with a structure to represent our error. This is just one possible solution. Obviously, the point that I want to pass here, just whatever it is, just choose a representation with some structure. So you can do things with it. So for example, you're going to have a case class with an error code and a message. That's it. So if we do that, this is our final solution. Same as before, case class data with an email and a phone. We have a function, validate email, that returns a string and returns the validate nil of an error of a string. Same for validate phone. Validate data is basically the same as before. Yeah? And it works. It's beautiful. And the type will guarantee that we don't do stupid things. Cool. Little digression, the wonders of the pizza symbol. The pizza symbol is not specific to validated. You can use it with everything. Well, you can use it with most of the things that have a flat map. So it means that, for example, with future, you can write this for comprehension that will just run the futures in sequential order, meaning it will compute the 1 wait for the 1 to finish, then it will compute the 2, wait for the 2 to finish, then it will compute the 3, and wait for the 3 to finish and combine all of them together. Or, with this nice expression, you can just start them, all of them together, and just combine them, all of them. So this one is more performant. Obviously, the futures needs to be completely independent. Otherwise, you cannot do that. OK? So this can be used not just for validation. So this is super cool. Pizza symbol for the win. Cool, but we have done this little game. We've understood that, obviously, types are important. But yeah, obviously, we don't work with the forms that have just 2 fields, right? We do things that are pretty complex. So how do we apply all these patterns that we have learned today in our application? So these are my advice on how to import this into your code. The first step is to pick an error representation and stick to it. The whole application should use that error representation. Why? Because you are going to accumulate errors, and if you accumulate things that are different, it's going to be a mess, I guarantee you. If you accumulate things that are always the same, that have a common trait or something, it's doable. You can do it. But if you start having 20 million different representations of what an error is, you're going to be in trouble. The second step is to enforce everyone to use that error representation using alias. So this could be one. If you use this alias, you will basically force that the function will exactly return this error representation. And the third step that I think is the more important one is make it simple for your team. If you are enforcing some rules, if these rules are hard to follow, guess what? They're not going to follow them. And one way of doing this is to create a companion object that makes the initialization of all these things extremely easy. So this is an example of what we do at work. It's a little bit simplified, but the logic is there. So we have a representation of our error. There is a seal trait with the code, the message, and the values, where the code is just the string that the front end or whoever is consuming our API can pattern match on. And then we have case class that extend this trait, and it's going to be the case class that decides the status code of our response. So we know that if we have a list of errors and any of them is bad requests, the whole response is going to be a 400. Otherwise, it's going to be a 404. Again, this is just one way of doing it. There are many ways of doing it. This is our beautiful alias, and this is our companion object. So to create a validation, you just do validation.success, and you pass the value. Otherwise, you do validation.failure, and you pass the error. Why we have done this? Because our team didn't really want to remember that we're using a not empty list. They don't need to know all the implementation details to use this tool, and that makes it really easy for them. Another little thing that my team wasn't too happy about, we are a team of really diverse people, so I work with people with Ruby background, Python background, and they just started with Scala. They're not really used to the crazy symbol. The pizza symbol, come on, it can happen. It can become the pizza symbol one day. We just hide the symbol into a function that is called accumulate. So they can do validation.accumulate and pass all the values. Easy enough. Summarizing a little bit is what we have seen today. It's a little exercise that can be useful to really play around and understand a little bit more about any language, about any problem. Try to represent your problem in a simple way and try to ask yourself, is it good enough? What's wrong with this code? What I don't like about this code? Don't reinvent the wheel. There are many libraries out there that probably already do what you want to do. In particular, if, like me, you work in a startup and resources are limited, we want to focus on the real challenges of our project. We don't want to focus on these problems. Choosing the types is half of the battle. So if you choose your types right, you will see that your code will be really quickly a lot better. So take your time, do a few tries, and try to pick the type that fits your problem the most. And also, don't be scared of customizing your solutions, writing the cells, making your life and your team's life extremely easy. All the code that you have seen tonight is available on GitHub on this link. The best way of learning code is just to play around with it. So my suggestion is check it out, play with the code, convince yourself that it works or it doesn't work, and feel free to ask any questions about it just by opening an issue or a PR. I will post these slides online. That's my Twitter handle. So if you guys are interested in the slides, just that's what to follow. And if you want, have a look at my blog. And also, remember to rate this session and said that it was awesome. So thank you very much, guys. I guess we have time for questions. So are there any questions?
Thank you. Great talk. Have you got any suggestion how to structure validation within the application to be maintainable? I mean, when the application evolves and the model or the case classes that has to be validated change their shape, and validation always get messy and forgotten?
So the hints that I gave before are valid, but my suggestion that I believe is really important, in particular in functional programming, is function composition. So try to have a lot of functions and try to compose them. This way you can fairly easily handle lots and lots of validation. So the crazy symbol, the pizza symbol will work with lists or with any structure that is composable. Combinable. I'm trying not to say in semigroup, but now I miserably fail. So, okay, we got it. There is a semigroup. I'll tell you later what it is. So as long as you are consistent with the type that you return, it will be extremely easy to compose all these functions together. So at work, I work in the retail business. We have creative validation. You guys have no idea. And that's exactly what we have done. We have done functions that are dedicated to specific fields, and we compose them. They are dedicated to specific case class, and so on and so forth. So function composition is the key there. So try that.
How will you handle the situation when some fields are dependent on one another? Like if you have, for example, start and end date, and you want to validate that end date is like after start date.
Okay, I'll show you. What is it? This function will just take 2 parameters. So if your validation is obviously dependent on multiple fields, it's fine. It's just this function that is going to be a little bit more interesting than this. So at some point, you will have a function that is building the validation. And that's the one that it's going to take. Instead of 1 parameter, it's going to take 2 parameters. So that's not a problem. You can have as many parameters. Well, not quite. But in theory, you can have as many parameters as you want into a function. So that should work. Any other question?